Hello and welcome back to the third rail. In this video you'll find hopefully some useful information about the M-Track catenary system. It's a relatively long video, so I have indexed it so that you can quickly jump to the section you're more interested in. The Märklin M-Track catenary system was introduced in 1957 at the same time as the track system. It was marketed as a way to add more realism to the layout. First of all, from a cosmetic perspective, electric locomotives could run with their pantographs up. And from a technical perspective, this is a working catenary system which can provide power to electric locomotives. This extends the capabilities from an operational perspective on the layout with enhanced multi-train operation. You can have a steam locomotive or diesel locomotive taking its power from the track and controlled via one transformer, and on a separate circuit have electric locomotives controlled by a different transformer. This allows to set, for example, different speeds for two consists traveling on a same line. This catenary system was produced for a period of over 40 years. During that time, it received changes as new elements introduced in the track system required it. The system is made of a series of elements. We have various types of masts, which are meant to support overhead lines, which come in different shapes. We also have cross sections, which are meant to be used mainly in stations or in areas where we have up to 4 parallel tracks. And we have also a series of masts which are made to support the cross-section elements. So let's have a look at the working principle of all that. A standard Märklin locomotive receives its power through the center studs on the track. The current is used by the motor and the return occurs via the wheel to the two outer rails. With the catenary system, this changes. It's the equivalent of lifting the center rail and providing an equivalent function through the overhead line. So the current travels now from the overhead line through the pantograph into the motor, and the return occurs as before via the wheels through the two outer rails. There are little levers on all analog locomotives pre-2010 that can be used to switch the operation from the center pickup shoe to the overhead line. As a result, the system is extremely easy to retrofit. There is no need to change any accessory or its connectivity. The only thing that needs to be taken care of is the replication of the isolated sections used for braking or stopping areas on the layout. The elements of the catenary system can be combined to form what I would call some basic building blocks. These building blocks can in turn be replicated in the required areas around the layout. This makes the installation and planning much easier. For this build, I'll be needing a few of these basic building blocks. The first one is the simplest one. It's a straight or curved section, basically 2 masts and a piece of overhead wire. The base of the mast is engineered to fit around the profile of the track bed. To set it up, it's simply a matter of sliding the mast base under the track bed and then press fitting the track into the base. The result is a very strong bond or fit. You can even shake the track and the mast will remain firmly attached to the track bed. So of course I need another mast to be able to attach the overhead line. We'll clip that into place and there we go. We are ready for the line. I just need to find one with the right length. There we go. The overhead line is made of a type of wire which is very flexible yet sturdy. It can be bent into shape as required. There are some little rings on each end of the various species of overhead lines, which are meant to fit at the top of the mast, of course. The top ring fits into the hook at the top of the mast. I'll attach the other one just for stability, although it's likely to fall off. There we go. Then the bottom ring of the overhead line needs to be pushed onto the little lever spring on the mast, like so. Then we just need to repeat the operation on the other side. So top ring on the hook and bottom ring onto the little lever spring again. These overhead wires come in different lengths to adapt to various scenarios. We first have the longest piece, which is the 7019, which is meant to be used on straight sections of track only. Then we have two slightly shorter sections, the 7018 and 7278, which are meant to be used on curves and shorter straight sections. To cover different lengths, we also have some compensation sections which are engineered to interlock into each other using a male and female connector system. So we have the two basic elements, which are the 7014 and 7015, which are male and female connectors on one side and mast connectors on the other side. So they simply interlock into each other, as you can see on the screen, and I can simply slide them back and forth to adapt to the required length. So I'm just going to set up a shorter run on the little track section at random. Then I'm simply going to grab my compensation sections and attach them to the mast, as I did with the longer section earlier in the video. Same system, equally as simple or fiddly. I've got a camera between myself and what I'm filming, so it's a bit difficult to do this at arm length. But as you can see, it's standing in as stable as the longer sections. If we need something a bit longer, we can use a little intermediate section which simply slide into the relevant connector on each end of the other two sections. Then I can simply adapt them to the required length and reattach the end of the section to the mast. And there we go. So far, so good. Let's have a look at the next building block we'll need, which is to be used with the turnouts. Now, with the turnouts, we've got an added complication, which is we have a curved section branching off a straight section, and that needs to be replicated with the catenary system. For this purpose, there is a piece of wire, reference 7013, which is engineered slightly differently. It's got a mast attachment in the middle and a male connector on one side and a female connector on the other side. This piece of wire is meant to take care of the curved section of the turnout. So before installing the section, I need to put together a combination of wires. I need, of course, the piece of wire for the curve and two additional bits, which are the same compensation bits we saw earlier in the straight building block section. These simply slide into place and that will form a longer piece of wire which will then be ready to install above the curved section of the turnout. So I now need to set up a few masts in order to be able to install this piece of wire. I'll zoom out so that we get a better view. There we go. So I'll start by placing a mast just before the entrance of the turnout. I'll just clip it into place. Click, there we go. Now this is where the center of the piece of wire we've just made will be residing. I can then take care of the exit of the curved section, where I need to place another mast. And for stability, I'm going to attach an additional mast slightly ahead of the turnout. So, ready to fit the wire. I'll start by attaching the middle attachment. There we go. Then for stability, I'm going to attach the end located before the turnout area to the mast there. Let me just adjust things slightly. There we go. Hook, lever. We're all done. And we can now look at the curved part of the turnout. So I'll start by attaching the wire to the mast. So I might need to readjust the mast for distance a bit. There we go. Then it's another hook lever job. And if we look at the configuration now from above, we can see that the wire is slightly curved, but it's not quite right as far as the position over the track is concerned. It should be towards the center so that it's aligned with the center contact. And so that's where the flexibility of the wire system comes into play, and we can bend the wire by simply pushing parts of it between the fingers until it has adopted the required shape. Time to take care of the straight section of the turnout. So I will need an additional mast for this, which I need to position opposite the one that I have placed at the exit of the curve. So I'm going to place my mast, we'll clip it into place like the other ones. There we go. So I now need to set up a piece of wire. I'll reuse the compensation bits to cover the distance between the entrance of the turnout and the exit of the straight section of the turnout. So I simply attach one side to the mast I used for the center of the curve and the other side at the end of the straight section of the turnout. Now we need to run a few visual checks. First we need to check the alignment of the catenary with the center contacts on the track. They need to be as close as possible. That seems to be okay in this case. And the second thing is to check the height of the two little sections over the curved and straight area of the turnout. If they are not at the same height, pantographs are more than likely to get caught in between, and that's something we'd like to avoid. Now let's look at another type of directional pieces of track, which is the crossing. Now the Märklin crossings do not allow the installation of a mast in their center, which means we can't reuse the same type of construction as for the turnouts. So for crossings of all types in the M-Track system, Märklin developed a specific piece of catenary wire, which is reference 7072. It is meant to be positioned right above the crossing and is held into place by adjacent pieces of wire. This part can be bent into shape to adapt to the required angle, as with any other piece of catenary wire. To install it, I will need to set 4 masts up around the crossing area, which I'm doing now. The masts need to be positioned at the same distance from the center, roughly. Then I can look at my crossing part, and I need to make sure that the cross in the center of the part is facing downwards. Then I'll need to put together a little assembly, and for this I need some compensation bits again, either female or male, depending on where they are attached to the part. And once that's done, I'll have a 4-prong spider type contraption that I'll be able to install over the crossing area. I then need to bend the various parts of this assembly into shape so that they fit neatly around the shape of the crossing, and then it's just a matter of attaching this assembly as you would any other piece of catenary. There again, we'll need to check that the wire is aligned over the center studs on the track, so it might require a bit more bending here and there to get to that stage, but all as simple as it was with the turnout. We can now look at how to bring power to our overhead wires, and this is done via a slightly modified type of mast called a feeder mast or a supply mast. There's various references. We'll look at the most simple one, which is the feeder mast. It's got a little piece of red wire which is attached to a metal strip at the back of the mast and conducts the power to the hook section of the mast attachment for the wires. It clips into place like any other mast we've seen so far, and catenary wire, of course, is attached also the same way. We'll need to use these feeder masts in our next building block, which is the isolated section, which you need, for example, for a stopping section ahead of a signal. So isolating the section is done using some special pieces of wire. It's reference 7022. They're easily recognizable because they've got a cut and they're held together with a little piece of Bakelite or plastic depending on its age. So one side attaches to the mast and the other side is meant to attach to a compensation bit similar to the one we saw earlier in the video. They simply slide into a female compensation bit, and we can adjust them for size and attach them at one end of the isolated section. And it's a bit fiddly because I've got the camera between my head and my hands, so a bit complicated, but we're there. We then need a similar combination for the other side of the isolated section. So it's just a matter again of sliding the two required pieces together, adjust them for size and attach them to the mast. And once we are done, we'll have set up an isolated section which is receiving its power independently via the feeder mast in the center of the section. There we go, we are done. These isolated sections are connected to signals via the little connectors at the front of the signal base. The power mast needs to be connected to one of the outlets there. It doesn't matter which one. And the other outlet should be connected to the power source for the overhead line. It could be another feeder mast or a connection from the transformer powering the catenary system. So when the signal is open or green, it will let the power through to the isolated section, and when it's shut it will simply cut the power there. All pretty simple. So far everything we looked at didn't require any tool for assembly. Now there are other parts of the catenary system for which we do need tools, and we'll have a look at a few of those. First we have the case of the three-way turnout, which is a frequently used piece of track. There the configuration used for a simple turnout would simply physically not work. So we need to get a few things out in the shape of a few nuts and bolts, a screwdriver, and a few pieces of overhead wire. The nuts and bolts are referenced as a fastening kit number 7004 in the Märklin program. The pieces of overhead wire are a 7018, which is a standard straight section, and two intermediate pieces of catenary, reference number 7023. The longer section of wire will need to be sandwiched between the two intermediate sections, and each intermediate section will then be bent in the direction required by the shape of the three-way turnout. So I'll quickly put the assembly together so you can have a look at how it should look like, using all the components I listed before. The whole thing takes about a couple of minutes to put together. So once everything is firmly attached together, it's just a matter of bending out the two intermediate pieces so that we have a three-way turnout type of shape. Then we can set up this assembly. I need a few masts for this. So I need 4 of them, which will need to be positioned at the entrance and at each exit of the three-way turnout. I'll always start by setting up the center piece of the assembly, position the masts as required in the process, and then I grab a few compensation bits which I attach to each of the intermediate pieces we've attached to the assembly, and then in turn fasten those to the masts at the exit of the three-way turnout. And we are done. Then it's just a matter of performing a few geometry checks as we did for the previous turnout. Basically alignment with the center studs and a check of the height of the catenary. There are also other uses for the fastening kit, of course simply to attach a few pieces that tend to be sliding away from each other all the time, but also in the context of two interconnected curved turnouts. Another configuration that would require a few tools are the cross spans. Where 3 or 4 parallel tracks are present, it is possible to use a specific piece of catenary called a cross-span. There are 2 versions of them, one that covers 3 tracks and the one I'm presenting now, which is made to span over 4 tracks. The cross-span section are meant to be used with some purpose-made masts. They come in various shapes. We have the standard mast, which is a simple base and a mast. And we have a lamp mast, which looks exactly the same as the standard mast, with the unique difference that it's got a little lamp and a bulb and a bit of wiring going through it. In both cases, masts have got a base with a few holes through which screws need to be inserted. The mast is not stable enough to be used in a standalone or freestanding fashion, so it will need to be screwed down. The crossspan has got a series of hooks and little spring lever on each side that are meant to fit into slots that are present on the side of the mast. So it's just a matter of locating the hooks over the slots and then slide the crossspan down until the spring lever locks into place, like so. Then we need to repeat the same operation on the other side. So there again we locate the hooks, then slide the entire crossspan down until it locks into place, and that's it. We've got our little assembly ready for the next step. Overhead wires are attached to the bottom of the crossspan section. For this we need to insert a few isolators between the two bottom wires on the crossspan section. They're called isolators because they're made of plastic and do not conduct electricity. This allows the operation of several circuits of catenary on the same crossspan. Pretty neat. All isolators are made of a single piece of plastic with a little clamp in the middle. This clamp needs to be fully engaged before installation, or you are going to break your isolator piece. To install these, we first need to position them in between the bottom wires of the crossspan section. They slide into little slots on the isolators. Once the isolator is upright, we can then disengage the clamp. That's a bit fiddly and tiny. And then we're ready to attach the overhead wire. So we need to insert the wire onto the two bottom wires of the crossspan section and then slide the overhead line onto the isolator, and then we can re-engage the clamp. And that's it. Our wire is now attached firmly into place and is very unlikely to move. So of course, if we had two pieces of wire, we'd need to attach the clamp only after the second piece was installed. For situations where there is an additional line running in parallel to the existing 4 lines or 3 lines, there is an additional accessory that can be attached to the mast. It's a 7525 cantilever arm, which works on the same principle as the crossspan section. There's 2 little hooks and a lever spring. It's just a matter of inserting these little hooks in slots present on the other side of the mast, pushing them down until the mast locks, or the spring locks into place. In this case, we would now have 5 parallel lines equipped with overhead wire. I think that with this we have now covered the vast majority of the elements of the catenary system. Now all these building blocks I described are meant to make planning and installation easier. Let's have a quick look at the planning, for example. In this context, since you know how many elements a given building block is made of. It's a matter of placing these building blocks and then multiplying the number of building blocks by the number of elements to figure out what is actually required to complete the installation. Let's have a look at a simple track plan to probably better illustrate this. So here I have a piece of parallel track joined together by turnouts at each end. So I'll start with placing basic building blocks, which are the turnouts. So in this case I've got one turnout on one end and one turnout on the other end. Then I'll need to fill the gaps in between these two turnouts with as many 7019 pieces of wire as possible. The remaining gaps will then need to be filled with some compensation bits. Because I know how many masts are required for each building block, I can then quickly calculate the number of masts required with simple maths and a few subtractions here and there. There are a few useful formulas that can be used in this context, as well as plenty of other information I probably didn't cover in this video, available in a few bits of useful documentation, and I would say that they are definitely worth a read. I'll start with the original user manual that came in the box together with some elements of the catenary system. You'll find plenty of useful information and diagrams in there. Another useful source of information are the official Märklin catalogues. They contain all sorts of information regarding the geometry and what is needed for what. I would recommend to pick a catalogue from the 70s to the mid-80s because it will contain the entirety of the Märklin catenary system. As mentioned before, the catenary system evolved over time, so anything from the 60s will work, but might not be complete. Another very useful source of information, as well as inspiration, are the older m-gleis book, the track plan books that Märklin published. Here is a copy of the 0390. As you can see, there's quite a bit of information on setting up the catenary system. So if we move to a track plan from this book, we can see that we have on one side the track plan and a description of all the tracks required to set it up, but there's also a catenary section for most of them, which will list all the elements required. They're also a good source of inspiration if you're unsure of how to set up a certain configuration that can then easily be replicated to whatever you are doing. As far as availability is concerned, the M-Track catenary system is really widely available still. A quick look at any auction site of your choice will soon throw up a few results. It's even very frequent to find items which are still in original condition, in original packaging, even sealed, and have never ever been used. Right, that was a lot of information. I think we've had enough for now. So I'd like to thank you very much for watching if you've made it that far. I'd also like to thank the existing subscribers to the channel. If you haven't, I suggest you press the subscribe button and hit the notification bell to receive notifications of new uploads on the channel. It's very rewarding to see that people are so interested in my content that they use the feature. Thank you very much again. But for now, bye and see you soon on the channel.